Hi everyone. Just giving a couple more minutes for those who are just about to join. So be with us. We're gonna start in 2 minutes. All right. We still have time for people to join, but just before we jump straight to the webinar, let me just briefly introduce ourselves. What is Ideas, what we do, and why we do that. So again, hi everyone. On behalf of Ideas, I'm very excited to have you all today for our weekly webinar. Today's topic is about formulating your career path in data science. But before we going to jump ahead to the webinar, let me just give you a small presentation about Ideas. So big thanks to everyone who can join us today. And for those who are watching this video on our YouTube channel, hope you can join us online next time. So Ideas is International Data Engineering and Science Association, and we are a nonprofit organization. So basically, we are very excited about data science, machine learning, AI, and blockchain, and we are sharing this enthusiasm with others. And we're here to connect these passionate people about data science backgrounds with each other to share the ideas, the thoughts, and just simply collaborate. So our mission is bridging the gap between academia and industry. This is our small roadmap. We started in 2016, and we are moving on and hosting conferences across the whole country. 3 years ago, our first conference was held at USC campus, and later we started growing rapidly, organizing conferences on different topics in New York, Chicago, Boston, LA. The huge one, upcoming one, is a SoCal conference in Los Angeles Convention Center. This one is happening on October 26th, so go ahead and register. Apart from the conferences, we'll also conduct hackathons. This is Photo Gallery. This is the very first one, SoCal conference at USC. This is one, Blockchain Leadership Connect in New York, Chicago Blockchain Leadership. SoCal conference in Pasadena 2017. This one is the last year SoCal conference. We had a lot of speakers, and this year even more speakers coming. So yeah, different topics with different interesting speakers. You can check our website for more information on upcoming conferences, and there are also you can sign up for a weekly newsletter with information on upcoming webinars, hackathons, or other conferences. So, and don't forget to join our LinkedIn and let's be connected. This one, yeah, just some photos. And this is our website. This is our email. We also have Facebook page, Twitter, YouTube, and this is QR code for our YouTube, where you can find different videos and past webinars. So now let me introduce our wonderful speaker, Lyuba Glauchova. She's the founding chair at Deep Learning World. She leads advanced machine learning projects for high-tech firms at major research universities in Silicon Valley. She previously served as a research analytics consultant at Stanford Graduate School of Business, and she's a yoga teacher, which is so cool. So welcome, Lyuba. We're very excited to have you today, and we can't wait to start. So I'm passing the whole presentation to you, and thank you again.
Great. Thank you so much, Dalia. It's a pleasure to join, and thank you for the wonderful introduction. I'm very excited to be a part of this. So welcome to Formulating Your Career Path in Data Science. So I'll go ahead and share my screen here. Share screen. All right, great. So hopefully by now, we're all dialed into the right place. So my name is Lyuba Glauchova, and it's my goal here today to help you demystify this space. And what do I mean by this space? I mean the data science space. But first, a little bit about me. As Dalia mentioned, I lead and execute data science initiatives at high-tech firms as well as research universities. So I'm a consultant, and I also preach what I practice by serving as the founding chair of Deep Learning World and speaking at events and webinars such as this one here. I received my master's in analytics from University of San Francisco and my bachelor's in both applied math and economics from Berkeley. So that if there are any Cal Bears on the call, go Bears, yay. And I have a pretty rich analytics past. In addition to the consulting that I did at Stanford Graduate School of Business, I also worked in high-frequency trading analysis, catastrophe risk modeling, and quantitative marketing, just to name a few. And I have a life outside of data. So I teach yoga and I'm passionate about all things human performance. So if you love geeking out on wearables like the Oura Ring, intermittent fasting, all of those sorts of things, get in touch with me via social media. I would love to connect with you on those points. But enough about me. We're all here for data science. So let's go ahead and dive into the contents of this talk. So about the talk, first we'll do a little bit of an intro so you know a lot about me already. I'd love to learn a little bit about you, about the people who dialed into this call, as well as introducing data science as a concept. We'll talk about what it means to be successful as a data scientist. And we'll talk about the technical career paths within data science, which is why we're all here today. And by technical, I mean, so there are a lot of different career roles and career paths supporting data science initiatives, including various types of management, be it people management or product management, various strategy individuals and C-level executives. I will be covering the career paths of the individuals doing the hands-on, nitty-gritty, in the trenches work of data science. So those paths, as we'll cover them in depth later, are listed here. And for those of us diving into data science for the first time, approaching this might feel like approaching a five-way fork in the road. But for those of us in data science already, we know that this five-way fork in the road actually probably feels a little bit more like the intersection pictured here. So it's a little bit chaotic, a little bit crazy. My goal here today is to delineate some of these paths, create a little bit of structure amongst the madness and complexity of data science. So let's dive in. Data science. So I'd love to know how many people here are data scientists. If we could have an interactive session, people raising their hands electronically. If everyone could raise their hand and let me know if they're already a data scientist on this call.
So we have 2 people already.
And how many people are dialed in total?
Well, we have about 15 right now. So
2 out of 15. Okay, great. Yeah. Awesome. Wonderful. So 2 plus 1 more. I consider myself a data scientist.
Yeah, me too.
Excellent. Okay, great. So we have 4. So even though there are various different types of job titles that fall under the data scientist umbrella, such as consultant, or maybe even strategist or catastrophist. I've worked with a catastrophist before. It's a very cool job title, but also I would consider him a data scientist. Ultimately, it's a very big umbrella, which we're delineating here today. So what does it mean to be a data scientist? This slide is a bit of an homage to one of my favorite movies, Death Proof. Death Proof is my favorite Quentin Tarantino flick, and according to Quentin Tarantino himself, it is his least favorite, his worst Quentin Tarantino flick. And he's actually said that if he's forced to make another movie like Death Proof, it will be his last movie ever. But if there's a Death Proof #2, I'm willing to take that risk. I can't wait. So in Death Proof, we learn just enough about Stuntman Mike, or in this case, data scientist Mike, to keep us guessing. So I know we have 3 other data scientists on the call. I hope none of them are the sociopathic killer like Stuntman Mike in Death Proof. Great. So for those of you that are not data scientists, what is your current title? You can type into the chat box. Let me know what your current title is. So I'm typing consultant, even though I am a data scientist.
We have system developer intern,
Oh, excellent. Okay, great.
principal engineer in microservices at Kubernetes IoT,
Okay, engineer, excellent. Yeah.
data analyst.
Data analyst, cool. Okay. Okay, so we have a pretty broad range here already. So question for everyone in the room, not just the data scientists, but really data scientists, I'm looking at you for this one. Who can give me a one-sentence definition of data science? Again, feel free to use the chat box.
We also have investments advisor.
Investment provider.
Investment advisor.
Oh, advisor. Okay, very cool. Okay, so for those of you savvy with the chat box, anyone want to be bold and take a shot at a one-sentence definition of data science? No? Okay.
Yeah, I believe they're shy a little.
A little shy. So what I did, I was a little shy in presenting and preparing this presentation. I just went to Wikipedia and I copied and pasted. So there are a lot of definitions out there. So one that's out there, and I was hoping to get a feel for the room and get a little bit of variety. But we'll start with this one. So it's a multidisciplinary or multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data. And Wikipedia further goes on to say data science is the same concept as data mining and big data, in that it uses the most powerful hardware, the most powerful programming systems, and the most efficient algorithms to solve problems. It all sounds very exciting, which is why we're dialed in here today. I would disagree with this definition in that I don't think data science is the same thing as big data, but that's topic for another conversation. But it highlights that there's no one right definition. It's a very nebulous field. And on top of that, it's always evolving. Yes, you caught my bluff on that. It's not multi-interdisciplinary. It is either multidisciplinary or interdisciplinary. But that highlights the fact that when I first made the slides, Wikipedia had interdisciplinary, and then when I went back and rechecked it, it had changed to multidisciplinary. So even the definition on Wikipedia, in typical Wikipedia style, is always changing and evolving. So I just made it the middle ground. Sue me. Okay, so anyone feeling bold enough to give me a one-sentence definition of machine learning? And again, chat box away.
Come on.
You know the secret now. Wikipedia is the secret. Okay,
yeah, you can copy and paste.
Yeah, copy and paste. That's how all successful coders do their craft. Copy and paste.
Yeah. Someone suggested, Jing suggested statistics.
Statistics, yeah. So statistics is a big portion of machine learning. So Wikipedia, again, the resource behind this quote is a scientific study of algorithms and statistical models. So whoever said statistics, right on. And computer systems, so sort of algorithms, stats, computers, to effectively perform a specific task without using explicit instructions. So it's a little bit different from data science, but there is an overlap, hence the Venn diagram here. And in that overlap, I would put computers and machines. I would put algorithms and models, something that we saw echoed in both of the definitions. And I would also put science or the scientific method. However, there's also a lot of space where the two do not intersect. Data science is a largely industry term. So when we're deriving insights, we're really focused on deriving insights for the purpose of identifying or evaluating key performance indicators within industry, or perhaps to identify which products to recommend to our customers. And machine learning, only until recently, has started to permeate into industry as well. For the past several decades, it was largely reserved for academia. Although we are seeing now machine learning trickle into industry as well, in terms of machine learning researcher or machine learning scientist being certain job titles. And on the flip side of that, we're also seeing data science enter academia. In that certain universities, such as Stanford, have data science initiatives. And now these data science initiatives are usually largely funded by industry. So again, industry and academia are coming together to further data science and machine learning. Okay, so what about AI? How does AI fit into all of this? So this is a pretty controversial topic. And I'm going to be bold and say that AI is a sexy pipe dream. The term itself has little to no substance and provides practically no value on top of machine learning and data science. So since we're not here to build our careers as snake oil salespeople, salesmen or women, and since we're likely not interested in industry over academia, I will go ahead and skip over AI, skip over ML, and focus on data science. Great. So success. Now that we know what data science is, what does it mean to be successful as an individual in this field? So let's take a moment to set our intentions, take some deep breaths, and bring to mind two highly successful industry professionals in data science. Does anyone know who these two people are? If you do, type it in the chat box, either left or right name. Do we have a winner, left or right?
Everyone guessing Andrew.
Andrew, okay, so Andrew,
Yeah.
What about on the right? Did anyone get the one on the right? Any guesses? Any names?
Even I don't know.
Yes. Yes,
No,
Hillary Mason, yeah.
Yeah.
Be a celebrity at this point? She has a very strong name, but she's still very prolific in the industry. But that's a very good point. It's sort of how much hype is there versus how much are they actually producing. But yes, so the two have been recognized. And for those of you who don't know, Andrew Ng is a computer scientist, inventor, business and executive, investor, and entrepreneur. You may know him as the co-founder of Coursera, co-founder of Google Brain, VP and chief scientist at Baidu formerly, and also adjunct professor at Stanford University. But really, go Bears. And then Hillary Mason, when I started following her, she was chief scientist at Bitly, which is, that URL shortening site that we all love so much. And she's since then founded Fast Forward Labs, which was acquired by Cloudera, where she now heads their machine learning. So she's still doing big things. And she is the data scientist in residence at Accel, co-hosts several industry community events, and is a recipient of numerous awards such as Forbes 40 Under 40 Wants to Watch, and Fast Company's Top 100 Most Creative People in Business. She's also a published author. So it's pretty impressive. And wow, these two combined, that's a lot of success. So let's get grounded. What does it take to get here? Now that we see what success can look like, how do we really get there? Who has seen this diagram? Show of hands. How many people do we have?
1, 2, 3, 4. Or
Nice. Okay, cool. So about 1/3 of the room, not a little over 1/3, not bad. So this is Drew Conway's. If you want to look it up, I've included the URL at the bottom here. A famous illustration of the skills one must master in order to become a fully competent data scientist. And it's a pretty old diagram, but I feel like it's reigns true to this day. And it doesn't look like that much, but there's a lot that lies behind each one of these components. So on the left in the red, we have the programming skills. On the right in the green, we have the quantitative acumen. And in the blue, we have the subject matter expertise. And now we've all seen job postings that require a PhD, 5 years of work experience, and despite not being explicit about it, face it, they really want a 25-year-old white male that looks like a carbon copy of Mark Zuckerberg or that guy from Silicon Valley, but also with the quantitative and the entrepreneurial chops to boot. It's a crazy, crazy combination. And no wonder that people are talking about a skills gap. These expectations are extremely unreasonable. The pool of potential candidates fulfilling these specific requirements is non-existent. It's just impossible. And someone who has such unrealistic expectations is likely not someone that you want to work for. But what if you already find yourself working for someone like this? Well, in that case, you are not alone. Many data scientists are looking for new positions, ones perhaps where expectations are better aligned with reality. And to demonstrate this, according to a 2019 Stack Overflow survey of 90,000, 18.6%, so nearly 1 in 5 data scientists and machine learning specialists said they were looking for a new job. That's huge. This is coming in second to just academic researchers. I've met multiple people out in the data science world that have said that they just keep going to interviews, even though they're happy with their current position. They just go to interviews just to keep those interview skills fresh, just in case there's something good out there. So there's a little bit of a revolving door phenomenon in data science. How do we get off this crazy ride? How do we keep ourselves from going on before it's too late? So what successful employers have identified is how to break down their ideal candidate into multiple roles coming together to form one stellar team. And each role falls under the general umbrella of data science that I mentioned before, but it also allows the individual their own focus, an ownership stake in the data science initiative. And as a successful employee, you can help your employer by identifying and leveraging your skills and interests in the right role. So onto the roles and onto the career paths. In no particular order, we'll start with the analyst. Now I know we have at least one analyst dialed into this call. Now, when I mention analyst, it can be a business analyst, a data analyst, an investment analyst, etc. So in general, all of these roles are concerned with extracting meaningful insights from data. And we saw that echoed in the definition of data science. These insights are specific to the industry, highlighting the need for subject matter expertise, which is why you see the analyst heavily weighted in that gray box on the blue circle, which is a subject matter expertise, and a little bit less in the red of the CS and the green of the quantitative. So the questions faced by the analysts are usually in terms of what's happening now. So the analyst may need to run and interpret the results of a model such as a linear regression every now and again, but likely they won't need to decide on how to fine-tune something like a deep neural networks learning rate. So quantitative chops a little bit less, And in addition to that, the data is usually more or less well-structured and architected, already residing in a database. So the analyst may benefit from advanced SQL skills, but they're likely not likely to need the hacking skills necessary to acquire data, set up and administer databases, and set up and administer development pipelines. So again, a little bit less on the actual CS or computer hacking skills. Instead of focusing on these pipelines and models, the primary goal, the primary focus of the analyst is to communicate insights to end users. Those end users being either external clients, product managers, perhaps C-level executives. So as an analyst, you'll need to be a strong storyteller. And in answering this "what is happening now" question, the analyst is keenly aware of who is asking the question. Answering it in a way that is geared towards the target audience requires not only knowledge of the material, but also knowledge of the subject matter of the audience. So it's a role that requires cross-functional collaboration. You'll likely be the middle person between engineering and implementation, and strategy and management. It's a really fun space to be in. And large corporations have spun up entire internal consulting teams tasked with answering this "what is happening now" question for various teams within the organization. So again, a lot of focus on storytelling, collaboration, a lot of communication skills, extracting meaningful insights, subject matter expertise. Now, because of this heavy focus on communication, the interview is the analyst's or potential analyst's place to shine and the chance to shine. So at the interview, you can show that you're cognizant of the target audience. So when you're asked for how you would present or deliver your results, be sure to inquire about who the target audience or the end user is. That will show that you're keenly aware of these communication skills and communication differences between the different target audiences. So is the end user or is the audience an executive concerned with key performance indicators, or is it an engineer concerned with systems integrations? They can be faced with the same question, but the answer will be completely different for you. And on top of that, you can take some public speaking classes, presentation classes, you can join Toastmasters, you can seek out a mentor. You can volunteer to give a lightning talk on a technical topic at a local meetup. Meetups are great. Presenting technical material to a wide-ranging audience is an extremely valuable skill set and will definitely set you apart as an analyst. Okay. On to engineers. So the engineers implement the systems used by the analysts, amongst many other things. And there are actually two main buckets that engineers fall into: big data or large-scale data infrastructure engineers, and deployment engineers, whom I refer to as sort of the software engineers of data science. So I'll start with big data. Big data or large-scale data infrastructure engineers are the new, bigger, and badder database admins. They work with transferring data, managing storage, pre-processing data, and administering the accessibility of large data. And these days, the position is likely to involve cloud computing, such as AWS, Google Cloud, Microsoft Azure, or others. And each platform is pretty unique, but there are parallels, and many organizations are using multiple platforms or trying to stay platform agnostic. So as a potential large-scale data infrastructure engineer, my suggestion would be to demonstrate that you know what it takes to set up a multi-terabyte data set for querying on one of the platforms, and talk about options that there are for setting it up on other platforms. Why would you choose one platform over another? Furthermore, how would you integrate the two platforms together? So be familiar with the questions that the end users are asking. If you set up a platform, who is on the receiving end of this platform? Is it an analyst typing queries into a system? What kind of queries are they typing in? Is it a machine learning engineer prototyping models? Is it a deployment engineer setting up systems? So again, familiarity with who the end user is of the product that you're delivering is key here. So you'll need some subject matter expertise in order to understand your end users and subsequently their end users. So who the management and the customers are. It's sort of a multi-layered approach. And now the deployment or software engineers. I see these, as I mentioned, as the software engineers of data science. These individuals work with researchers to deploy machine learning models. So they know how to take a piece of R or Python code implemented on a small subset of data and how to deploy it on large scale data, perhaps even taking it one step further and implementing it in an online learning model that is continually updated using new data. So again, these are the software engineers of data science. And like the big data engineers, there are a lot of tools and technologies involved. And what both of these roles highlight is the need to stay on top of the latest tools and technologies. So again, it's heavily weighted on the red circle, which is the computer science, the hacking chops. You'll need to continue educating yourself about the landscape of the tools that are out there, attending meetups, attending conferences. It's a very exciting, like bleeding edge space to be in. And for the most transferable skills, I would suggest whichever employer that you go work with, it would be in your favor to work with someone that's using open source tools and the latest tools and technologies. So if they're on AWS, on GCP, maybe Microsoft Azure, they're using R or Python, heavily weighted towards open source as opposed to some sort of canned machine learning tools and technologies. All right, finally, scientist researcher. So this is the person engineering models in R or Python or a more low-level programming language. This model building requires a keen understanding of the underlying data, of course, but also the modeling methods. So we have heavy focus on the green circle there of statistics and quantitative acumen. Most often, the data is already well formatted. Good, they don't have to do everything. Cleaned and architected by either the big data engineer or maybe on a smaller scale by an engineering analyst. So as a researcher, you likely won't need to communicate insight, but you'll need to understand the business and the end users enough to make sense of the data and apply the relevant modeling framework. At the highest level, this person, the machine learning researcher, is applying a bleeding edge methodology. So you may think that a PhD degree is definitely required here, but that's certainly not the case. So multiple high-level machine learning practitioners have said that the single most important qualification is a demonstrated interest in reading and implementing research papers. It's much easier said than done. But if you're going down this path, make sure that your GitHub page reflects not only Kaggle competitions, we all of those, and those are sort of great badges of honor. However, those Kaggle competitions usually sort of use a predefined set of models or set of techniques that we already know work well. The data is already cleaned and ready for ingestion. I would suggest work through research papers, try implementing what the research papers propose. And oftentimes research teams will release their code and or their data to the public, giving you, the aspiring researcher, a wonderful opportunity to try and implement and perhaps even improve on their findings. And in fact, there have been Kaggle competitions in the past that are research focused, so you can sort of try to bridge that gap. But whatever you do, remember to start simple. So the latest research and latest techniques may be very exciting in their complexity and their innovation, but don't forget to test out a baseline case. So how does something that the latest researchers are implementing, how does that compare to a simple model such as naive Bayes or linear regression? That's a wonderful place to start. So you can see sort of what the value add of the latest research is. And though these individuals are less likely to be reliant on the latest tools, this role does require you to be knowledgeable about the foundations of some of the latest research. Again, a great way to do that is to join one of the meetups here. So there are multiple meetups that focus on research papers and also deployed data science and industry. And again, my suggestion would be to join, absorb, speak. Very valuable. Okay, last but not least, what if you want to do all three? So given a business problem and a data set, you're able to prototype a model, you're able to deploy it, and you're able to demonstrate the value of it to decision makers and C-level executives. You want a position that will allow you to build on all of your skills. Well, friends, in that case, you are a data science unicorn. Congratulations. Build all the skills. So remember several slides back, I said that people who are looking for a unicorn are likely not the people that you want to work for. Well, in this case, that's not necessarily true because you are looking for them. So you'll likely find this type of opportunity at a startup, hiring their first data scientist. It's very exciting. So be prepared for unreasonable expectations. Be prepared to do a lot more of the engineering than anything else, because you'll need to lay the groundwork before you do any streamlined big data pipelining or sexy neural network modeling. And unfortunately, more often than not, they'll sell it long before you build it. So you'll need to leverage your subject matter expertise and your communication skills to forge ahead the data science development, and also to gently push back when management and sales overshoot and overpromise. It's pretty much bound to happen. So it's a tough pair of shoes, but someone's got to fill them. And in this startup-hungry day and age, there are many opportunities. So if you're looking to be a data science unicorn, all the best to you. Lots of opportunities, that is, until this bubble bursts. ... So on that note, that wraps up the content that I have here. So again, just to walk through what we covered 5 different technical career paths, different buckets underneath the general data science umbrella, various types of analyst type positions, 2 types of engineering positions, big data and deployment, the researcher, and of course, the unicorn. So that wraps up the content that I have for this. We have some time for questions. I would be more than happy to address them. So Dalia, any questions out there?
Okay, thank you so much, Yuba. Right now we don't have any questions, but feel free to ask everyone. I actually have a couple of questions. So first of all, when we start looking for a job, there's a lot of data scientists, like data science job posting, and they expect a lot.
Yes.
And they don't actually break down the position as you broke it, as an analyst or data engineer or big data engineer or stuff like that. They just simply put data scientist. But then you can look through through all the things, the requirements they're looking for, and you can see they actually expect a lot. And those are not just startups. Those are actually big companies like IBM, even Google, all FANG companies, basically. They're looking for this unicorn.
Yes, everybody wants a unicorn, right?
So my question is, what do you suggest? Do we have to do our PhD in data science in order to get to those sexy FANG jobs?
No, and I mean, I would definitely suggest these are the types of jobs, and someone mentioned this in the chat, that it may be the case that they don't really know what they want. What you can do coming into such an opportunity, I'm putting it in air quotes because we don't know, is know where you're coming from. So as a data scientist, what do you see as your biggest strength? Which of these potential roles, potential paths do you most closely identify? Now, you don't necessarily have to box yourself into one, but there may be one that's dominant for you, and then maybe a little bit less than the other, and then you have a number 3 spot. Know that coming into an interview, and when you're being interviewed for this crazy expectation position, see it as an opportunity to interview them as well, and really try to get a feel for what are they really looking for, because everyone's looking for everything, right? Everybody wants everything that they can have in one person. Why hire a whole team when you can pay just one person, right? But really, maybe they really want their initial person to be someone implementing the latest bleeding edge methodology. They already have all of the engineering done. They have the data in the database. They want someone to test out the latest and greatest machine learning techniques. Maybe they don't have anything implemented, and you will need to build up the data science from scratch, in which case it will be heavily an engineering role. And ultimately, maybe later on, we'll get into more of the modeling and the researching. Does that answer the question?
Yeah. Thank you so much. Actually, our chat box is bursting. So the first question, when do you think this bubble will burst?
That's a very good question. So this is actually one of the talks at Deep Learning World this past summer. So it just happened a couple of weeks ago in Las Vegas. We had an individual giving a lightning talk on when the next recession will hit. So this individual used an LSTM model, a recurrent neural network model, to try to predict when this bubble will happen. And he was able to show, drumroll please, that it will not happen within the next 12 months. The problem is the model is highly unreliable if you try to scope it out to anything further beyond 12 months, or the predictive capabilities, even of this very hot LSTM model, kind of drop off after 12 months. So I can tell you, based on his research, that it will not happen within the next 12 months.
Well, that's kind of promising, although it would be better to know the future expectations on that.
I know. But hey, when it happens, we just have to be adaptable, shift quickly, move on our feet, maybe take up farming, like in that one Matthew McConaughey movie where the whole world kind of plummets and they start farming and then they go into outer space. Yeah, Interstellar. That's it. Okay.
All right. The next question from Albert: can you comfortably apply to jobs that you do not meet some requirements?
Yes. Yeah, I would say that should be a big yes for everyone. Definitely don't shy away from jobs where you don't meet all of the requirements. I don't know what more I can say on that. The best thing that you can do is walk into, because some of these positions where you apply and you don't meet all the requirements, you will get an interview, and show up and know where you're coming from and be confident of your own strengths and what you could potentially bring to the table.
Yeah. That's true. All right. Thank you so much. So the next question from Paul, it's actually a big one. So Luba, I do consulting too, and I'm seeing more and more moves towards hiring ML engineers and data engineers, generally, while an increasing number of course are, okay, so increasing number of hiring plain vanilla data scientists. Are you seeing this as well?
So that's an interesting point. What I've observed amongst my network is a lot of individuals that started off at sort of low, the sort of entry level data scientist positions, eventually a lot of those individuals ended up going into engineering type roles. So perhaps that's sort of being echoed by also the actual opportunities that are out there. The need for engineering is very hot right now. And I think people are starting to realize that, and they're starting to realize that maybe the broad term of data science is not quite accurate for what they're looking for. It's more on the engineering end. So maybe it's a reflection of a more educated employer, a more educated team.
And if it's possible, is it better to dismiss skills you don't have or years of experience you don't have? This is the same question from the Albert.
Sorry, could you repeat the question?
Is it better to dismiss skills you don't have or years of experience you don't have, so just skip them?
Either one of the two. Which one would be better to dismiss? Is that?
I'm not quite sure. So Albert, can you clarify your question, please? Okay, just a second. Yeah. So let me just read the other question, right? So would you like to provide some suggestions of changing from data analyst to data scientist? How to change our career from data analyst to data scientist?
Yeah, so I think more importantly, sort of identifying what actual components of what you do you want to do more or do less of. So perhaps as a data scientist, you could be wanting to focus more on actually engineering the data and the pipelines, and working with big data, maybe working on some sort of parallel computing, distributed infrastructure, the latest AWS, Google Cloud infrastructure, or maybe you want to instead work more on more complicated models and more complicated modeling, more forecasting as opposed to the what is happening now. Or maybe you want to focus more on all of the above. So the sort of the question of which of your skills do you need to build out in order to get from sort of the position that you're in now to the position that you're envisioning. And in my view of the world, and again, this is my view, my presentation, my view, that the analyst falls under this data science umbrella. It's one of the 5 paths that I talked about. It was the analyst, the engineering, big data, large scale data infrastructure, the engineering deployment, and the unicorn. So analyst is very much the data scientist in my eyes. The forte, again, of the analyst is the communication, knowing your end user, being able to communicate those insights from the data. So again, it's sort of where are you now and where do you want to go? That's the ultimate question. So if you want, maybe provide a little bit more clarity, and I can dive a little bit deeper in that.
Yeah, so Shannon, could you give some details on your question? I think she's probably seeing this way, like he's probably data analyst and he wants to transition to data scientist. And what are the steps or what to do in order to change the position?
Yeah, so I mean, it's sort of again the question of what are you doing now, and what do you want to be doing, irrespective of the title. I understand that sort of having a data scientist title is hot right now, and maybe perhaps could potentially lead to a higher salary or more career opportunities. But sort of what is behind that desire? Do you want to do more modeling? Do you want to do more engineering? Do you want to do less of the communication of the results? That's what you want to do more of, and what you want to do less of will sort of dictate how you transition that.
So Shannon is suggesting something like put some projects to in the resume or stuff like that, or maybe develop a GitHub account, right?
Yes, yeah. So if you're looking to get into the modeling, more of the forecasting, the predictive modeling, building out a GitHub page is great. So you can put your projects on there, and by projects I mean Kaggle competitions are fantastic. If you really want to demonstrate, if you really want to be like the bleeding edge machine learning researcher. You want to do the latest and greatest techniques. You want to get into deep learning, the LSTMs, the recurrent neural networks, image processing, all of that. Then try looking at research papers and see if you can start to make sense of them. See if you can try to implement. There are a lot of research papers that already come with some code and some data that you can start playing around with. And there are Kaggle competitions that focus on research as well. So you can start small or you can dive into the deep end. If you're looking to do more of the engineering and the pipelining, there are lots of educational opportunities for getting up to speed on cloud-based infrastructure, because chances are you will be, if you were moving in that route, the company will be working not on on-premises servers, but more in the cloud. So I would suggest get up to speed on AWS, on GCP. These places, including Microsoft Azure, they have certification, but I would say don't dive into certification. Familiarize yourself with the landscape of maybe one particular one, and see if you can get started on, say, setting up a large data set on, say, AWS. How do you set up a large data set? How do you start querying? What are the different options for querying a large data set? What are the different options for spinning up compute resources and distributing work on one of these? So again, the question is, where do you want to go? And how do you show to your employer that you've done work on this? Well, again, the GitHub page can display some of your work with AWS or GCP. You can also start a blog, join meetups, network a lot with individuals, speak to what you've done, and that will show others that you're sort of a key industry player beyond the role that you're in right now.
Thank you so much. So Shannon, I hope this answers your question. Yeah, this really helps. Okay, the same question was skipped from Albert. If you were to have to choose one or the other, which is more negative, to having a deficit of years of experience or have a deficit of particular skills? Probably the particular skills he means are like Python programming or stuff like that.
Yeah, I would say definitely a thing to focus on would be the skills as opposed to the years of experience, because we all know that years of experience can mean different things for different people. I've heard that working at certain large corporations on one specific task, there's really not that much learning that happens. You sort of get pegged into doing one thing and you have a lot of years of experience in machine learning, but you're sort of implementing one thing over and over again, fine-tuning the model. Whereas if you're doing that at a startup, it's non-stop learning on many different levels. So the years of experience there will mean something completely different. So I would say, yes, disregard. If you're going to disregard one thing, definitely disregard years of experience. But I would say don't shy away from disregarding multiple requirements on a job posting, and just definitely casting a wide net and walking in confidently to wherever that wide net leads you. Could you please clarify? There was a request to clarify, but I'm not sure what the clarification pertains to, the request.
Oh, this is my request for Howard.
Okay.
Yeah, okay. Some comments, which is, yeah, thank you so much. And I hope, Albert, your question is answered. Yeah.
Okay.
Oh,
Okay, good. Excellent.
I also have one more question. You've mentioned for those who would like to develop research skills as a data scientist, read some papers if you don't have PhD background. Read
Yeah.
some papers. Do you have in mind any like hubs or platforms with data science related journals? Or maybe you have something in mind, some titles and names of good data science journals.
I mean, I would say start. This is a very tough question. Um, there is a repository of papers called Archive. That's ARXIV. But there's a lot on there,
Yeah.
and without knowing exactly what aspect of data science you're interested in, it can be sort of challenging to dive into that. Definitely subscribe to some newsletters. There's Data Science Weekly, there's KD Nuggets. A lot of these are industry focused, but they also have some research facets as well. There are podcasts. One of my favorites is Talking Machines. They also focus on research papers, and in kind of approaching those, they're sort of the wide nets. They can help you identify what aspect of the field you're interested in. And once you're interested in that, just Googling that, and Google has a wonderful sort of like research paper search tool, going into that and just seeing what pops up, because what pops up on top is likely the most widely cited one. Just start there. And that can be a little bit intimidating if you're just diving in and you're like, okay, I'm going to implement this. But don't walk into it with sort of the end goal in mind. Just walk into it with a curious perspective and seeing what's out there.
All right. Thank you so much. We also have a couple of more questions from Andrew. What do you think is required to become a manager in data science?
Oh, good question. Definitely a lot of the skills that I mentioned on the analyst path, strong communication skills, being able to collaborate, being a strong team player. A lot of these sort of the engineering and the researcher and even the unicorn paths, they're sort of geared towards one particular silo, whereas the analyst, you're less focused on the implementation part, but more focused on the people skills part. So I see a lot of people starting out as analysts and ultimately moving on to directors and managers and all of that. So I would say focus on that and focus on building out the leadership skills, the confidence, the networking, and moving into the management role in that route.
Thank you so much, Diba. Andrew, I hope this question is answered. The next question is from Wei. Could you please recommend some industries for entry-level data scientists to jumpstart their career?
Some industries?
Yeah, some entry-level data science jobs are available.
Oh, I would say which industries do not have? All industries. But I mean, I think in terms of like what is hot next. I mean, if you're sort of stepping into the industry and you want to stay ahead of the curve, I think where where data science is headed in sort of the long run is Internet of Things. Right now, we're sort of looking at data sort of from the static perspective. We're moving into what's next, obviously. But right now it's sort of like, what do our customers want? What will they want next? It's sort of looking at data as it's coming in from the real world and applying that. Ultimately, what will happen is machines not only interpreting the data, which we're working on right now, but also changing the data, and ultimately having it be a bit more of a fluid environment. And really, a lot of the big data that's coming out, that's being generated right now, is by Internet of Things, and it's only getting bigger. So whether you're actually doing the machine learning part or the engineering part, both of these will be heavily driven by Internet of Things, manufacturing, I would say that's definitely a hot industry to get into. But in terms of which industries right now have data analyst roles, all industries, it's hot.
Thank you so much, Luba. I hope your question is answered. The next question from Andrew. Oh yeah, will the slides be available? I think, yeah. I think, Libo, you can send us your slides and we can later post a link under the YouTube video with your slides available. Right?
That sounds good.
Okay. The next question is, do I need to have a few years of industry experience when I apply to a data scientist job in a different industry?
I would say no. I mean, you can definitely get industry experience from the job itself. The skills from one industry should be transferable to another. What's key in the process of shifting between two industries is the demonstrated interest in learning. So walking into an interview and saying, I know this is a new thing for me, but I'm very excited about this because X, Y, and Z. That's definitely, a lot of these skills apply, of course, like we said in the previous, or addressed the previous question, a lot of these skills apply to pretty much every industry that's out there right now. And don't shy away from shifting gears and trying different industries and following your heart wherever it may lead you.
All right. Thank you so much, Luba. Vivian, I hope your question is also answered. Well, we don't have any questions anymore. Yes, I think that's pretty much it. And actually, the time is up. So yeah, if you have any questions, guys, we can allow maybe 2 more. If no, that's it.
Yeah, and if not, if there are follow-up questions, feel free to connect with me on LinkedIn. Would love to continue this via LinkedIn messaging or whatever other social media platform is out there. So we can take this offline.
Yeah, that's great. Thank you so much, Luba. Thank you for doing this. Really appreciate your effort, your talk. Today was very unique session because it was more interactive and we had a lot of questions. And thank you so much for guiding our data science career. And yeah, everyone says thank you.
Yeah, great. Thank you so much, Dalia. And thank you everyone that dialed in. It's definitely a pleasure. And a lot of wonderful questions, very rich discussion. I look forward to continuing some of these. If there are follow-up questions, again, LinkedIn is the way to go. It's my pleasure. Thank you so much.
Yeah, I'm going to start a small, I think we do have one question.
Okay.
Oh, no, I'm sorry. This is just a thank you. All right, I'm gonna start a small poll. For those who are still online, can you please spend a couple of minutes leaving your opinion on our webinars and stuff like that? I will really appreciate that. Yeah, thank you so much. See you again next week.
Great, thank you. Bye.
Thank you. Bye, Luba.